Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Jeremy who has just completed the course ROS2 Basics using Python, and he's going to be giving us a presentation on that. So without any further ado, let me now hand over the platform to him so he can begin his presentation. Alright Jeremy, whenever you're ready.
Wonderful. Hello everybody. So how should we proceed? Should I eventually do the test? We see how it behaves and then we go through the codes together?
Yes, that's better. Yeah, so
Okay.
Let's see it working and then we can talk about it as we go.
Wonderful. So, oops. Just get the workspace first and then launch my main file basically the whole follower cache and min launch.py. So normally now, if everything goes as planned, the robot should align to the wall, go, realign, and follow the wall follower sequence. So yes, now it should speed 90 degrees to get facing to the wall, and then if it's too close, yeah, it just makes a little move to get closer from it. So within that 30 millimeters radius, and now we will see it zigzagging around and trying to avoid any obstacles. As you can see here on my terminal, I just decided to make a logger to just display the information of the odometry. And it might take a bit of time to just run. I don't want to bother the viewers if there is any. I would just like to say that, well, if I get within the 50 centimeters where the starting point was, normally the robot should stop, but in the meanwhile, I suggest that we just quickly get over my presentation and showing how I solved that issue. So I felt that maybe a PowerPoint would be a bit inappropriate to explain code, so I decided to make a board where I just displayed the kinds of, let's say, samples of my code, and I thought it would be easier to then show the interdependencies of my code, and in the meanwhile, I'll let the robot run on the side, and hopefully it will behave.
Yeah.
So just before we get into that spaghetti kingdom of mine where I just displayed every messages, just for quick information, my name is Jeremy. I'm a mechanical engineer. I worked for a year as a designer in Canada, but then I decided that I wanted to study some more, so I decided to apply for a master in the University of Luxembourg. And to be honest, my real robot application experience, I don't have any, so that was a first time for me. I'm not really experienced as a programmer too, so if you have any comment on my code and things that I would have done better, I could have done better, I'd be happy to have your feedback. But without further ado, let's just hop back into the coding aspect. So the exam was made of 3 different sections, and we'll go through each one of them to discuss the logic of my code.
Yes.
So the first part was to create a package. I decided to do it on Python because I don't know C++ really well, so Python would make it easier for me. And so I decided to move to the ROS2 workspace. I created the wall follower package with all its dependencies. And as it was suggested, we created a Python code called wall following.py, which is the one executing right now, guiding the robot to move along the walls without colliding into them. So here I won't go into detail into all the imports because I just followed what was shown in the classes. What is important there is that I created my first node that I called obstacle detector. And what is important there was to create a subscriber to the laser scan topic. So as defined in the class, the topic is just sending me continuous informations about beams that the LiDAR sends in every direction. And to then guide the decisions of the robot. Oh, here you see that, just by the way, the robot stopped. It realized the action that was asked to do, but we'll get into that in the future.
Yeah. That's good.
So the laser scan here has a callback function. This is where we instructed the decisions that the robot had to follow depending on the measurements taken by the scanner. So here I just created a subscriber, and it has to listen to laser scan. So laser scan here was the message, and it was subscribing to a topic named dash scan.
Mm-hmm.
And also I decided to publish a function that I will call later in my laser callback that is called steer publisher, because it steers the robot. And so this one listens to, like, sends the message twist to the robot and by the topic command velocity. So there, what I decided to do, it was a bit of a play and tweak to find out how does the laser scan properly work.
Mm-hmm.
So I realized that it had a total every message of 7 and 20 beams, so
Mm-hmm.
they were called indexes, and I had to arbitrarily find out which one was the front and which one was the right. So for a total of 7 and 20 beams for 360 degrees,
Mm-hmm.
the front one was the index 360, and the one that would be perpendicular to it on the right was the index 180. So
Mm-hmm.
from there, I could tell the robot measure front and measure right. Depending on those two values, then steer as you can.
Yeah.
So here, just for a simplicity, actually I did not invent it, I just took it from the class and adapted it. You called usually the twist message action. So since ROS is based on object-oriented programming, I can just call the message from action, but instead of having to type twist every time, I could just say action linear X when I wanted the robot to have a certain velocity going forward, or angular Z when I wanted it to spin in a certain direction.
Mm.
So, as said in the requirements, what we had to do was to apply those rules. So, if the wall on the right was further than 30 centimeters, we had to spin and get closer. If we were too close, we had to spin the other way around and get further from the wall. And if we were in between, well, don't do nothing, just go straight forward. So that's what I did here in my code. So I cheated a little bit with the values. Instead of 30 centimeters and 20 centimeters, I added a buffer of 2 centimeters. Because on my first run, I realized that since the robot has some inertia, sometimes it would just go further than the distance, and if I didn't code a proper way to bring back, it would just stop because it was out of reach of the boundaries I had set. So that way was just a little way for me to add some buffer. So the idea here was to say, from the start, get an initial velocity and don't do nothing about it. If you are too far from the wall, spin around Z in a negative sense. So since we follow the right-hand rule technique, negative Z would be spinning clockwise and getting closer from the wall on my right. Else, if it's the opposite, well, spin counterclockwise and go further without stopping the linear velocity. So it allows me to have a little sweep curve instead of just a zigzag. And else, last if was if the wall in front of me is less than 50 centimeters away, initiate a spin and stop your linear velocity. So if the wall is getting too close, you stop, you spin, and you keep on going. And every time I would get that message, I would then publish the steer publisher, which was basically saying, read the message, analyze, reset the values, and then tell the robot which way to go. So that was for my topic. And then as it was asked, we just had to create a simple launch file. Of course, we had to also modify the setup file of the package. But yes, the idea was just create a small launch file to test it out. So later on now, to the second step, it was about creating a service, the wall finder service. So same logic as before, I just created a new file, which was called wallfinder.py, also a Python file. And here was a bit more complex already. So what I did was creating a new node. I called it wallfinder service node. And the part that interests us is I still subscribed to my laser scan because I needed those informations. I still published my steer command because depending on the information I get, I had to re-communicate with the robot. But the interesting part here is I used the new message interface that was suggested to use, and I created a callback after creating a service. So same logic as for a topic. Since a topic is a continuous communication, a service is just a sent message with a request and a response. I had to create a callback once again to allow the robot to communicate properly. And so here, what I decided to do is in my service callback, I used the same logic as the one before, so I didn't reinvent the wheel. I guess it's the principle of ROS2 is having to do as little job as possible. So, yeah, once again, I called my twist method from the topic command velocity action, just because so that I could reuse my code from the past. I set an initial rotational angular velocity of 0.2 radians per second around my z-axis, counterclockwise.
Yeah.
And here I increase a little bit of the linear velocity. I put it to 0.1 meters per second, so 10 centimeters per second. So in the requirements, you suggested some information. I'll put that full window, maybe it's a bit more visible for everyone. So there I followed what you suggested. I just created I used a boolean in the interface message saying that unless there is no wall found, we'll see later on where I turn that condition to true, just do nothing. But if the lasers can find a wall, then enter to the logic and behave. Logic there was, well, from any position I would just say launch a scan, find every distances, and pick the shortest distance.
Okay, so
this is also shown here. Yeah, sorry.
Yeah, tell me something here. So if the response wall found is false, right? Is there any form of logging that you are doing so that you know as the developer that the robot is saying I have not found a wall?
I should have. I didn't do one here because I was aware of the message. I think I used to have one, but in the cleanup for the presentation, I probably just erased the code. That little get logger. Let me check.
It's a good way of handling things,
Perhaps
but I think you need to know, right? When things like these happen, you need to know so that you can be able to figure out, okay, my code is functional, it's just that it's saying it isn't found the wall, then you have to figure out what. But yeah, okay, let's go on.
I must have had one, but just as I've been cleaning a bit compulsively, maybe I got rid of that.
Yeah, okay.
But yes, I agree with you, it helps tremendously when debugging.
Yeah.
But then my logic was, so I just look around for those 7 and 20 indexes, which by the way were 360 degrees. Which one is the closest distance I have from the wall? I would then look into that list. What is the index value here? Index goal. This is the index of my shortest array.
Right.
Now, since I know that my front index is the index 360, I could define my goal. Well, I just have to make the distance between the two. That would give me a certain amount of indexes between the two. I know each indexes are half a degree, so I can define the angle that I need to rotate. So these are the value I called angle to rotate.
Okay, so let's talk about this more. So you're saying you're checking the shortest index, right? How are you guarding against the fact that the shortest index might be an obstacle?
There it might be an obstacle. I should have, in the best of world, maybe taken a couple of indexes and see if, well, there is a line or a connection between all of them.
Yeah, I think
there I did not, as a matter of simplicity, unfortunately, and it happened to me. Sometimes those little cone we have in the simulation, would be detected as a wall and cause an issue sometimes.
Exactly, that's why I'm asking. Maybe you need to. Actually, it's much needed to handle that case. But your method is. It works, right? It just needs something to be done about robustness. But yeah,
I agree. Yeah, exactly. So something I was taken by time. I had sacrifices were made. Unfortunately, doesn't look professional of me, but yeah, that's life.
Yeah, well, it's part of the learning journey, right? It's part of
exactly.
The learning,
yeah. And also, I had a certain point where it was working properly. I was afraid of breaking everything. Of course, I could just have made a copy of my code and edit it, but for the time being, I just decided to go with there. But yeah, sorry. So just getting back, because maybe I have to speed up a bit if we want to wrap it up on time.
Yeah, you got 5 more minutes. So yeah.
Oh, okay. It's not enough from what I had prepared. Anyway, so I'll go fast. I know the angle. The command velocity topic doesn't allow me to define a proper angle.
Yeah.
So I had to define a timer for the rover to spin the distance. Since, I got the angular velocity, I got the angle dividing the angular velocity by my angle would give me a certain timer that the action had to do.
Yeah.
So let's say I had to turn, per se, 30 degrees. I know I turn 1 degree per second. Well, it's been 30 seconds.
Yeah.
So there is what I done actually, and same logic as before. I would send a message to the steer publisher and adapt the velocity. So here it's just a schematics. I would look for the shortest ray. This is the wall. This is the buffer distance of 30 centimeters, and I would say, well, spin in the right direction, move forward, considering that little buffer of 30 centimeters. Go there, and then once again just spin 90 degrees to keep the wall perfectly on your right, and then start the topic that we've just done before.
Okay.
So just coding logic.
Okay. While we're still, I have to say this is a very nice presentation. What tool did you use? It says Miro.
It's Miro.
Yeah, it's a very nice presentation. Anyway, so while we're still here, right? What type of controller are you using? Any form of controller to make sure that the distance between the wall and the robot is kept constant? What's going on there? Because sometimes I saw that there was a lot of like deviation, so I want to know what's going on. Is it just an else if loop, or what's going on?
There, just as a simple matter, I just wanted to get close enough and launch the previous node that we had for following the wall.
Okay.
I'm not sure that I get your question. Once again, and blame it on robustness. I accept it. I just made it really simple. In the best of world, once again, if I had time, I would also have considered that maybe if I'm too close from the wall, just realign again. That's fine. Let's step back.
Yeah,
I
but
didn't put it in.
So ideally, the control loop that I'm talking about is the one that is called when the wall is found, right? So when the wall is found by the service, there is no need for you to keep calling find wall again, right?
I agree.
So you're gonna be switching to a different control mode. So for example, your action,
yeah, so
right?
that's
the action that's responsible for carrying out the task of following the wall is the one that's supposed to contain either a loop or some type of control algorithm that is responsible for keeping the distance constant between the robot and the wall. That's the one I wanted to know about.
Just a simple boolean that we had to find in the service, and the interface message was a wall found true. That's what I use here. If you found a wall, execute and send the value true, and then return the response back here. So that's where I was using that response wall. If I don't find it, don't do nothing.
So
if you find it, just execute that code.
Okay, so you are using the service to find wall as is like your control system. So that is being pulled over and over again to ensure the robot goes around the wall.
I don't believe, because unless I'm mistaken, let me check. Normally, from my understanding, there should be a spin once for my service. I just execute it once. My code editor. Sorry, here, source. I'll just increase the size a little bit. Wall follower, and it was wall finder. Which one of the two is it? Wall finder, if I'm not mistaken. No, I just spin it. Huh. But sending back the so here, once and yeah, I should have initialized it as false, running it, and then say that. Yeah, I should actually have put it, initialize the value of. Oh, there it is. My bad. It's false.
Okay.
I'm sorry. No. It's not initialized. Yeah, no. I couldn't explain properly what is going on here. I would have to test and use loggers, maybe to display the value, know what is the value considered, and find a more robust way to use it.
Alright. I'm also trying to find that. Let's see. Okay, so this is
that I had initialized it as wrong.
Open the wall following or wall following .py and let's have a look into that. So when below,
oh yeah, custom interfaces.
No.
It's my service. Oh, sorry.
I wanted the script.
Yeah, wall following.
Yes, wall following .py. Yes, this one. So here's where we're supposed to find the control logic that I'm talking about. So you send go. Okay, scroll to the bottom a little bit. Right.
Yes, okay, so I didn't create a proper callback. I mean, a proper, let's say,
Okay, so I think, well,
feedback to it.
in the your laser scan callback, right, that it is doing it. Okay, it does call the action to publish command velocities and things like that, but yeah, ideally that's where the control is happening. So let's go back to that bit, because I want you to take me through what is really going on there, so that we can be able to answer, did you use any type of controller or something. So yeah, right there, right? Yeah, this is service callback.
Would you like me to go down?
Just hang on a little bit. Alright, this was supposed to be the job of an action, isn't it? So you do understand that the differences between an action and the service, right?
Yeah, an action is basically a service, but it's just that it uses a topic to send a continuous feedback.
Yeah, you could say that if you want to break it down, but the point is, you can leave it running and it does not block your processes, right? So this was supposed to be implemented using an action, but the way you implemented it is seemingly some kind of a mix of topics and services, and then you're having to publish command velocities on a particular topic. It does work, it's just not the recommended way of doing it, but I mean, for the purposes of what we have seen so far and its capabilities on going around the track, it is satisfactory, I would say. But I still want you to be able to at least explain what it is that that is responsible for controlling that distance that you said we want to keep it between 0.3 and 0.2, right? You have to have some form of control loop somewhere.
But the control loop is in my wall following file. As it was suggested, it's the topic that actually guides the robot that should enable the controller.
All right. Yeah, it's understandable.
Do you know, it is just what I understood here, at least that was my interpretation of the requirements here. This is what behaves as my controller.
Okay, so
it is just that my service acted as a way to it just acted as a way to get closer aligned, and once it's aligned, then
yeah,
start
then
the
you
controller that was used.
Yeah, then you don't
follow.
have to call it anymore. All right. I think that's good. That's good. Okay, let's go on.
Okay.
We have taken.
I will just quickly go then. Yeah, I'll go really fast. Maybe there, in the end, an action is just a mix of between the two things that I had to do before in a different optic.
So this part exactly.
But,
I think this part is the most important that we haven't talked about. So let's finish it up on this one. Yeah.
So I created that action that just gives me back the odometry as a feedback and has a goal saying that if you get closer from the original position, stop the whole process. The process being the first topic I had that was guiding the robot. So there I created a subscription that I called odometry callback. This is just to listen from the phone call that the scanner is sending me of continuous data. And sorry, not the scanner, the odometry, so the measurements of the wheel. It's really simple. I just created a subscriber to the topics odometry. And there I just listen to the pose. That pose gives me the position X and Y, and I just called that variable last odometry. It's just one float, one for X, one for Y. And then, oh sorry, here, I don't know, maybe I moved a bit. Everything moved a bit. Where is my callback? Oh, execute callback. This is what is interesting here. And also, sorry, something happened with my presentation. Everything shifted a bit. Oh, it's just a bug of display, but anyways, I just created a action server that would send back the information I had and also maybe stop the robot if the decision was taken by the client.
Okay.
So what I decided here is to make an execute callback from my action server. this action would just initialize. I make one list for X, one list for Y, taking my last odometry, and I would stack it on top of each value, so it was a list that would increase in size as I was using as the code was running.
Yes.
And so really simply, then I just set the action result value as the result of the odometry, and same for the feedback. So those are the values that I define in my message interface. So this is used for just Boolean decisions of, oh, do you keep on going or not?
Mm-hmm.
Do you send a feedback or not?
Okay, understandable. Yeah.
There, I decided to go in a little bit of an inception with feedback. Within my action feedback, I created a timer that said every 1 second, do an action. That action is called feedback measure. And now let's look quickly what it does. It's a really simple trigonometric function. It is just appending the last odometric value taken for X and Y.
Mm-hmm.
And then it just makes the difference. So I created a dx, a dy, and I just measured the hypotenuse distance between the last I1 and the next to last value I had. I saved that value into a variable called distance since last measure, and in my total current total value, which is the current total distance measured by the odometry here, current total, I just added my last measured value. So every 1 second I measured the distance from my last point, and I add it to the total distance traveled by the robot.
Okay.
There, what can I add quickly before there's anything interesting? Here is the action. So what I decided to do is, since I have to be within a range of 5 centimeters from my initial position, what I decided to do is, if I just launch it right away, it would be like, hey, yeah, that's good. We're already within the 5 centimeters, on the first loop.
So
I said, yeah. Oh, but it just happened to me, yeah. So that's why I'm talking about it. I just say, travel for at least 1 meter before being bothered by that condition. So that's what I say here.
Yeah.
Here, just if the current total is more than 1 meter and my Euclidean distance from the origin, which is what I received from my last odometric value, if it's less than 0.5 centimeters, then you just have to say that this task is done, send true, and then here it would be going to the final step. So if I say my goal handle is not cancelled and it's not done, keep on running that action.
Okay.
And there, so if the angle, if it is cancelled, just say, well, the goal was cancelled by the client. If not, the goal was completed successfully.
All right.
And then I just return the result.
All right. Thank you so much.
Finally, just adding, I just created a main launch file, added everything, and that was my main launch file that you saw executing on the robot.
Yep. All right. Thanks very much, Jeremy. Very wonderful presentation, and what a way of putting it across. So I really like the tool and the application. So that is very nice. Makes it easier to follow. And understand instructions. Thank you so much. So just hang around and we'll wrap it up here. Okay.
Perfect.
Alright everyone, this was Jeremy's presentation, and a warm congratulations to him